Boy.
Okay, so we're recording now.
Hey guys.
Anybody looks at it? Alright. So, because I don't want anybody to be left out, I'm ignoring y'all, by the way. Our quiz is Friday. Quiz is Friday. Some of you should be worried because you haven't been engaged in the learning process. Some of you come to school, but you sit here, and you do manage to breathe. But that maxes some of you out, apparently, during this last period. So we got a couple of days to engage
You look at me.
and learn the math. This is not hard. And honestly, if you've been here at Stars Middle for math, none of this is new. We just took little bits of things we've already studied and put them together. Okay, so you were supposed to do the evens last night. I'll talk about a couple of them, and then I'll go over number 3, which is what I asked you to do in the warm-ups, and I think I saw 3 people do it, so that's good. All right, here, it asks us to evaluate x value of -3. Well, we got to plug into the top piece because that's where x is less than 0. Isn't that the category that -3 would fall into? Yeah. So let's plug it in. -3 times 3 is -9. -1 is -10. Make sense? All right. This one, 4. 4 is going to fall into that category. This category contains values that we could write it like this, right? X is greater than or equal to 4. All right, so we plug in 4. 1 minus 4 is -3. Okay, let's skip down here to number 6 and go over this one. G of -3. Once again, that falls into the top one. So when we cube -3, we get -27. And -27 minus 1 is -28. All right, when we plug in 4, x value is greater than 3. That's where 4 would fall. So it has to go into this bottom one. 4 minus 3 is 1. 1 squared is 1. 1 plus 3 is 4. Okay, number 3 is the one I asked you to do during the warm-up. So -3 in the top one. So 2 minus -3 is 5. +4. Go in the middle, in the bottom one. 6 minus 4 is 2. What if I had asked you to find h of -2? Does that go into the top, the middle, or the bottom?
Middle.
Middle. Because we have the equal to, and it falls in here. So -2 times 4 is -8. And that is how we evaluate piecewise functions. First of all, we have to decide which piece of this function does that value for x fall into? And then we plug it in and get out the function, the y value, the output of the function. All right, any questions on that section? Let's move on. Okay, take a look at these. I think I'd like to go over number 3. So you check 1 and 2, and then we'll go over number 3.
We didn't do 2, did we?
Oh, that's right. You just did 1 and 3. You did the odds. Yes, ma'am.
Maybe I didn't do
This close. So what makes it just a line?
All right.
There's nothing around.
So let's talk about number 3.
Maybe like
You got it.
like squares.
Okay, so on number 3, we can look at the equations and tell we have 3 different lines. A line, and a line. plug in the value that they give you. If we started at an x value of -2, what is the corresponding y value? -1/2 times -2 is +1. 1 plus 1 is 2. So that's where I start, at the point -2, 2. It's less than, but there's no equal to. So when I plot that point, it needs to be open, not closed. There's no equal to, so it needs to be open. So that's where I'll start. Open circle right here at -2, 2. Now because this is a line from that point, all I have to do is apply the slope. So the slope is -1/2, which generally means down 1, right 2. But we don't get to go right. We don't get to go right, we can only go left. So instead of going down 1 and right 2, we're going to go up 1 and left 2. You have to do the opposite. So from this point, if we go up 1, left 2, up 1, left 2, and then it continues in that direction because we only have a starting point. We don't have a stopping point. Does that make sense for the top piece?
Yes.
All right, middle piece. The middle piece has a start and a stop. So if I plug in -2 for my starting point, -2 times -3 is +6. +6 minus 1 is 5. There should be a closed circle at the point -2, 5. -2, 5, closed circle. The stopping point. When I plug in 1, I get -3 minus 1 is -4. There's no equal to here, so this needs to be an open circle. So I'm going to put an open circle right here. Now 2 ways, because we know it's a line, we could just connect the dots, or we could verify that we did everything right by doing the slope. The slope of this is -3, so we start it here, go down 3 over 1, down 3 over 1, down 3 over 1. We did it right. Now we connect the dots. Now, the cool thing about the last dot is, it was open right here. But when we plug in the 1, there's no place to put it. So this is the y value. And we talked about this yesterday. That is a horizontal line. Y equals -4 is a horizontal line. So instead of drawing the entire line, we're going to start at the point 1, -4, and it's a closed circle. So what happens? It fills it in. And this is greater than, so we take this one and go right. Forever. Because there's no stopping. Does that make sense for number 3?
Is it just y -4?
Y equals -4. That's this piece of the function.
But like, is that the only one that's horizontal?
If there's no slope, if there's no x, if it's y equals any number, it's a horizontal line. So y equals 2. It's a horizontal line at 2. Y equals 7. Horizontal line at 7. Y equals -5. Horizontal line at -5. So y equals is horizontal. Which one's vertical? X equals. Will we have any x equals in any of our piecewise functions? No. Because if it was x equals, would it be a function? No. It would fail the vertical line test. So all we're going to have is horizontal lines on these. We won't have any vertical. If we did, it wouldn't be a function. All right, let's check number 5. The first part is an square root. Okay? It's been shifted left 4. This one has a start and a stop. And the great thing about this start is it's the same as the starting point for the square root, which makes it pretty easy. And the stop is our second move. Remember, with a square root, it's numbers we can take square roots of. 1, 1, 4, 2. So our stopping point on this one is that second move. That's the only part of the square root I get to draw. It had a start, it had a stop. Correct yours right now if you need to correct the square root part of that function.
doing figure something.
I had already checked the front when I walked around. I was just checking the back that time. Okay, let's talk about the second part of this function.
Interesting friendship.
Alright, the second part is just a line, and it only has a starting point, so we plot the starting point. The slope is +1, up 1, right 1, up 1, right 1, up 1, right 1, forever. Now, this open circle went right over the top of the closed one, and you can't even see it. And that's how yours should look. If we have an open circle on top of the closed one, you couldn't even tell. They look just like a solid circle. Any questions on number 5? Alright, let's check out number 7. Number 7 has a cubic part, and it's just the left half of the cubic. The middle part is a line, and this last piece is a parabola, but it's only the right side of the parabola.
You got one part right.
How's yours look?
The top right looks great.
Oh, no lie, I got it right.
Awesome.
Will you do me a favor?
Give me some. Do it, man.
Will you go back to number 2? I'll see what I did this right.
Appreciate it.
I will in just a
This
second.
bone.
Okay. Thank you.
Double!
Are we still recording?
We are. We are. Are you planning to come in after school to help me edit the video?
Can you like cut the audio and stuff?
I can. But I have to. It's a pain.
Oh, for real?
You should just leave it
Sometimes I do it. Sometimes I don't.
Just leave it on.
So
here
what if
we can
we've
listen
been
to
just
it.
kind of shouting random noises?
Then it'd be awesome because I could send that as an attachment to your parents and let them know at what time they should listen to their child's response.
This is going on.
She's totally done that.
I have totally done that.
You have?
Yep.
Blame it on its whole.
Did people like cuss or something?
That's 4 left.
I will say that at times, sometimes the interpretation that some of my students give their parents about what happens in the classroom and then what happens in the classroom don't quite align.
Yeah,
Yeah.
true.
Yeah.
They give their perspective.
But you are innocent until proven guilty.
Boom. Prosecution has the burden of proof. Learn that in legal environment.
Where's Paris?
What'd you say? Where's Paris?
All right. Today's lesson.
Paris.
Brussels for an
All right. Writing piecewise functions. We've already done this. We did it with absolute
I
value.
thought it was in France. Oh, it's in Belgium. That's where it's at. Is it?
So,
Because
today we're gonna just take the skills we've already learned and apply it to different types of piecewise functions. So we've already done it with absolute value. Now we're going to do it with some line segments that are not absolute value, arrays that are not absolute value, and then some other functions. Okay, so when we first started doing this, we went and we kind of drew in the fence. And we said, okay, we're drawing a fence where the vertex was. But we can kind of think about this the same way. These lines break up the function into their pieces. So we have an x value of -3 right here, an x value of 0 right there. And if we looked in between these two, we see this function, which is a line. It's a horizontal line.
So it's a
And the
Y.
equation for a horizontal line is just y equals the y value. What is the y value on that line?
2.
2. Now, if that's what we wrote, we would be indicating that it goes forever left and forever right, and this one doesn't. So when we write it as a piecewise, f of x really means the same thing as y. So this part over here takes care of the y equals. value right there.
I'm sorry.
And then
where are
we restrict our function because it doesn't go forever left and forever right. It was right where I always hide them.
Oh, you hit him from?
Okay, so this one starts at an x value of -3, and it continues to an x value of 0. Now, at the -3, it is a closed circle, so we can include it. But at the 0, it is an open circle, so we do not include it. So this is how it's written in the inequality. If you guys are more comfortable with the interval notation, you're welcome to use it, but I continue to use the inequality because that's what you will see on the ACT. Some of you got your scores back. On the SAT. So, we need to understand what compound inequalities, and in this case, how it limits the domain. Alright, now this is another line, but it's not a horizontal line. So, this line, we're going to plug into the y equals mx plus b, and we've already done that. Hayes, what is the slope of this line?
That would be 1/2.
1/2. It's up 1 over 2. Up 1, right 2. So it's 1/2. And then the y-intercept is right here. It's at -2. Now, this function also is restricted. This line doesn't continue forever. So we have to say for x values that are greater than or equal to 0. Because it starts here and it goes forever right. So we could also write it as the interval from 0 to infinity. Yes, sir?
It's not a good question for this moment in time.
Okay.
Do you write both of those or?
You can choose this one or that one. Okay, let's take a look at the next function. It's another line. Alright? Now, just like we read left to right, when we write piecewise functions, we want to do the same thing. Just have some consistency. So I'm going to always start with the piece that's furthest to the left. Alright, so in this case, it's this one. So this is a line. I got to go back into y equals mx plus b. The slope is up 2 over 1, up 2 over 1. So the slope is 2. Now, I cannot see the y-intercept. But if I continued my slope up 2 over 1, do we see that the y-intercept would occur at +3? Now it doesn't, because the domain is restricted. So let's restrict that domain. The x values for this function, so if I drew in a line, right here, what are the x values right there where it changes? Very good. Less than, or I could choose less than or equal to -1. So it's this line, but only for x values that are less than or equal to -1. Now, I could have just said less than and chosen to do the equal to on the next part. Yes, sir?
So, like, since the circle's closed, it's equal to, but you don't know which one.
You're right. So you pick.
Okay.
You get to pick. You
What
can
about
make
both?
the first equation be equal to or the second one be equal to, but not both.
If it was both,
Right.
Who knows
why
if it's
not
both?
Okay. When we talk about both, that would mean we'd have 2 points that if we did a vertical line, it would pass through. So we don't want to mess with the definition of a function. We can't have 2 of the same y values. And so if we put 2 equal to, that's what would trip us up in terms of a function. Alright, let's take a look at the right side. I feel confident that you guys can not only write the equation for the right side, but you can also write a correct restriction on that domain. Go.
Now can I ask a question?
go French.
Do they speak French in Belgium?
Yeah,
No,
they can.
What's the name?
Got a variety of
What's the
languages.
native tongue?
if the x is 0, would it be They're probably settled by French people.
Like right
Yep,
there.
you can.
Probably like French people settled by.
French people didn't sell anywhere.
They had to.
What are you talking about?
They sold Louisiana.
Yeah, but how do you think they got that?
What? I don't remember the Louisiana Purchase. 1802.
All I know is it was $15 Historically accurate?
For that little state, it looked like a little boot.
Wanna interject?
Thomas Jefferson.
What about this part?
Thomas Jefferson was like, man, that's a good deal. I ain't gonna ask it.
But he was like, man,
Ha ha ha,
this
to
is
the
deal
bank.
Negative one. But it's go to this way instead, because it's going that way, so that way. No.
No matter which one you pick.
Okay.
Alright.
See my socks?
Anybody's missed those, Andrew? I think they called it.
Thanks.
Alright, down one, right one, down one, right one, down one, right one. My slope is -1. Woo! So you can write -x, -1x, that's fine. And the y-intercept is the origin, 0, 0. So I could write +0, but I don't have to. Now, this is for x values that are greater than -1, because that's the x value right here where this starts. And because I chose to have the equal to here, I cannot here. Now, do you notice how I put an if statement here, and I put a semicolon
Is
there?
it the same?
It doesn't matter.
Alright, that's
You
what
can use either one.
Put me on.
Alright, let's do some more interesting ones.
Doesn't it be square?
We are going to do some in a second. Look at this. Look at this example right here. It's a little more exciting. Ma'am?
Would you stop the one where x equals 1? Is that where you'd stop?
On the previous one?
No. On the right side.
This one?
Would you
Start it here. Yeah, I'll get there. I'll get there. Alright, so it looks like we have some changes that are happening right here and right here. So these are where my x values are going to come into play on this graph. So I'm going to go left to right. I'm going to start with this function right here. What is the equation that represents that horizontal line? Y equals 1. Good. So a 1 goes right here. Now, this one only has a starting point and goes forever left. So its x is less than or equal to
-3.
Good. -3. Alright, now let's keep going left to right. Let's do that middle piece. Another line. So this one needs to go into y equals mx plus b. Let's count. Up 2/3. My slope is
2/3.
2/3. What is my y-intercept? 1. So it's 2/3 x plus 1 is the equation that would represent the entire line. But we only have this segment, and it has a starting point and a stopping point. What is the x value where it starts? -3. But it's open, so it's just less than, no equal to. And then we have the x value where it stops. +3, but because it's closed in, we have the equal to. Yes?
Does it have to be in that order?
Yes. When we write a compound inequality that has a start and a stop, we always go least to greatest every time. Left to right. Just like we read is the way we write math, from least to greatest. Left to right in terms of our x. Now, this last one has a slope of down to right 3. So it's -2/3. But we cannot see the y-intercept. So we have to count backwards. So we go back 3 and up 2. And the y-intercept would be at +2. Now, we know we can't go all the way back to there because it starts starts right here. And it starts with an open circle. It's a little hard to tell. But it starts with an x value greater than 3. That lets me know, even though my y-intercept is 2, I don't get to go back all the way there. Alright. So now the first 3 were just with lines. But we've learned a lot more different types of functions. Like, who can look at this move? 1, 1, 2, 4. What function goes 1, 1, 2, 4? The parabola, a squaring function. So we know this is a parabola.
Wouldn't that be a negative square?
And it is. Ooh, I like it. A negative square.
Good stuff.
Because it opens down its negative. Now, this actually happens to be the vertex. And I can tell because of the moves. 1, 1, 2, 4. So this point is the vertex. So this vertex has been shifted. How do I shift a vertex to negative 2, positive 1? What goes in here with the x? Positive 2, positive 1. Now this is only for x values that are less than negative 2. Alright, you try the middle piece.
That's easy.
Yeah, do that.
Alright, so that's just that horizontal line, y equals 1. And it goes from an x value of negative 2. And since I chose not to include it there, I've got 2 here. It could go the other way around. I could have included it here and not there. And I went ahead and decided to include it here. Now this last one, what type of function is that? Square root. So it's a square root.
How do you know if the line's going right or left?
You always go right.
Look at the arrow at the end. It's going right.
Well, it's going left on the left side.
This one's going left.
What's your greatest or equal to sign?
Left and down.
I know, but I'm talking about for the
How do
middle
you know
one.
these? Which
Yeah.
way they point? Okay. Because I always go from least to greatest. When you always go from least to greatest, then you have to use less than. Because that makes this number the least value and this number the greatest.
So if there's 2, there's always less than. It's always less than. If you go from left to
If you
right.
correct. If you have a starting and a stopping and you go from least to greatest, it's always less than.
Alright.
Alright, so this is shifted right 1, up 1. So right 1, up 1. And it's just normal moves for a square root. So it's for values of x that are greater than 1. Now I could have equal to if I didn't put it there. Alright, so no brand new concepts, but we're looking at it in a slightly different way. So you have 9 on the back to practice, but you also have the rest of class. So let's get started.